Okay, go.
Hi, in this video we are going to be looking at one problem taken from the IGCSE Add Maths exam paper. It is paper 1 from the October-November 2013 exams. Okay, paper 1, October-November 2013, and the question is number 10. So you can take a look at the question. I have written an abbreviated version of the question on the right, but I'm sure you can get hold of the question. Okay, it deals with coordinate geometry. We have A and B. Okay, the coordinates are given, -3, 2 for A, and B, the coordinates are 1, 4. We are told that there are two of the vertices of an isosceles triangle ABC. Okay, you can read the question, right? We are also told that this is not angle 90. Okay, we are also told in the question that angle B is 90 degrees. Okay, again, we are told that we have a triangle ABC. It is an isosceles triangle, and they gave us the coordinates of A and B, and they tell us that angle B is 90 degrees, and we asked to find a few things. Okay, let's have a quick sketch. Let's say this is A, -3, 2, and let's say this is B, 1, 4. Okay, and we have an isosceles triangle ABC, and they tell us AB is 90 degrees. So let's go ahead and draw it. Okay, so C can be here or here. Okay, so let's leave it there first. Okay, now they ask us to find the length of AB. That's easy, we can use the distance formula. So let me write the formula as well. AB, we are going to use the formula x1 minus x2 whole thing squared plus y1 minus y2 whole thing squared. Okay, so let's do that. So I have 1 minus 3 will be 4 squared plus 4 minus 2 will be 2 squared, and this will be 16 plus 4, 20. We are done. If you like, you can write this as 2 root 5, and that's it. Okay, so that's the first part of the problem. So let's keep that here. This will be square root of 20. Okay, now they ask us to find the equation of BC. Okay, now BC is perpendicular to AB. There's an angle 90 degrees. So first we have to go ahead and find the gradient of AB. So the gradient of AB is y2 minus y1. Let's write it down. y2 minus y1 over x2 minus x1. So I can write 4 minus 2 over 1 minus 3. This will give me 2 over 4, and that gives me a 1 over 2. So using the idea of m1, m2 equals to -1, I can write the gradient of BC as -2. So we know the coordinates of B. Let me write it here. We know the coordinates of B, 1, 4. We know the gradient of BC, which is -2. We can write the equation. Yeah, I like to use y minus y1 equals to mx minus x1. Let's do that. Y minus 4 equals -2, x minus 1, and you can write y minus 4 equals -2x plus 2, and you'll get y equals to minus 2x plus 6. Okay, bring the 4 to the right, and we are done. Y equals to -2x plus 6. So let's write it here. Y equals to -2x plus 6. That's the equation of BC. Now, like I said earlier, we have two possible locations for C. They're asking us to find the possible coordinates of C in the last part. and it carries 6 points. Yeah. So again, they're asking us to find the possible coordinates of C. So remember the important point, ABC is an isosceles triangle. So let's just assume that C is here first. Okay, let's assume that C is here. Listen, this is just a sketch. Yeah, there is no scale whatsoever involved. Okay, let's say C is here, and let's say the x coordinate of C, let it be h. Okay, let it be h. Good. Now if you say that the x coordinate of C is h, the y coordinate must be minus 2h plus 6. Okay, because it lies on that line. Okay, now we have settled that. The other thing is the part about being isosceles. Okay, so let's attempt to draw one of it. Yeah. Now, again, let me remind you, this is not to scale. I'm just giving you an idea of what's going on. Okay. Now we know AB equals to square root of 20. Now we can write BC equals square root of 20 because of the fact that it's an isosceles triangle. What you cannot do is you cannot say that AC is square root of 20 because that's a hypotenuse. Okay, that's a hypotenuse. So you can't do that. So BC you can write as equal to square root 20. So this will be, okay. So let's write BC. B we know is 1, 4. C will be h minus 2h plus 6. So we know that BC equals to the square root of 20. So let's write square root of 20 will be equals to, so x1 minus x2, we have h minus 1 squared plus minus 2h plus 6 minus 4, we are going to get minus 2h plus 2 squared. Again, I'm just using the distance formula. Okay, x1 minus x2 squared, y1 minus y2 squared. So I've got minus 2h plus 6 minus this, you'll have minus 2h plus 2. Great. Let's remove the square root symbols. Okay, in mathematics we call it what? Squaring both sides. So I have 20 equals to h minus 1 squared plus minus 2h plus 2 squared. Okay, good. So let's clean that up. 20 equals to h squared minus 2h plus 1 plus 4h squared minus 4 times 2 is 8 plus 4. Okay, just expanding. Yeah? H squared minus 2h plus 1. I've got 4h squared minus 8h, okay, plus 4. Now we need to clean this up. I don't need this. Okay. Okay. So on the right hand side I have 5h squared, and then I have minus 2h and minus 8h, so I can write, excuse me, I can write minus 10h, that's good. Then I have plus 1, I have plus 4 is plus 5, bring the 20 across, 5 minus 20 is good. Okay, that you can clean up on your own. Now I have a quadratic equation, 5h squared minus 10h minus 15, divide throughout by 5, I will get h squared minus 2h minus 3 equal to 0. So let's factorize. H, 3 and 1 minus and plus. So h can be 3 or negative 1. So we have the x coordinates. The possible x coordinates will be 3 or negative 1. Remember, this point C lies on this line. So y will be minus 2x plus 6. So we can plug in minus 2 times 3 plus 6. We have 0. And the other coordinate will be minus 2 times negative 1 plus 6. We have 2 plus 6 will be 8. Therefore, C can be 3, 0, or C can be negative 1, 8. Okay, so the possible coordinates of C, 3, 0, or negative 1, 8. and we are done.